Okay, so let's go over the instructions real quickly. Today we're going to be solving 1 and 2 step equations. This is a review of what we should know from last year. So, solving equations can be generally summed up in 4 steps. These are 4 very basic steps on how we solve any algebraic equation. Now we will learn some neat tricks on combining terms and isolating the term later on in this course, but this is a general description of the 4 things that you're looking for as to how you isolate a variable in an equation. Are there groups? Meaning, do we need to get rid of any parentheses or brackets? Are they all in one spot? Meaning, do we need to combine any like terms? Do we see the variable in more than one place in the equation? Is it alone? Meaning, do we need to isolate any terms through the inverse of addition or subtraction? And then, does it have a coefficient? Meaning, do we need to isolate the variable by undoing multiplication or division? So, let's take a look at what we have. If we look at the first question, we have a plus 5 equals 15. There's no parentheses. I only see the a in one spot, but I notice that the a is not alone. I have a constant with the a term. So the way that I'm going to get rid of that is I'm going to subtract the 5. What this does is it cancels it out on the left-hand side, and now my a is all alone on that side of the equation, which leaves me with an a is equal to 10. And that's what we get. If I jump off to something else, I have a negative 54 equals m divided by negative 9. There's no parentheses. The m is all in one spot. The term is isolated because there's nothing added or subtracted to it, but the variable is not. It has a modified coefficient. I need to undo either multiplication or division, in this case division, with the other. So if I'm dividing by negative 9, I'm going to multiply it by negative 9 on both sides. That will in effect cancel out the divide by negative 9, which will give me an m, and then I take 54 times 9. They're both negatives. 2 negatives will make a positive. 54 times 9, that will give me a 6, carry my 3, 45, 48. So m is equal to 486. On number 5, this isn't a one-step equation, this is a two-step equation. What we're going to be seeing right here is that there's no parentheses, no like terms, but I need to both isolate the term and isolate the variable. Now, isolating the term is important first. I need to get this whole thing by itself. I can't get rid of the 2 just yet. So I'm going to subtract the 5 to isolate the m, which will in effect cancel this out right here, and I'm left with a 2m is equal to 20. And now I can move down to the last step of isolating the variable. When I isolate the variable, I'm going to divide both sides by 2, which leaves me with m is equal to 10. If I move down a little bit further, on number 7, I can start on step 2. My variable is not all in one spot. It's in multiple spots. So what I'm going to need to do is I can either move all the e's to the left, or I can move this e to the right, which would leave my coefficient positive. So I am going to do that, which will in effect cancel that out over there. Now here, be careful. What I see a lot of students do is they'll subtract the e and they'll say, okay, 3e minus e is just 3, because they think they're just getting rid of the e. Don't forget, we're combining terms, which means 3 e's minus 1 e is actually 2 e's. So I know I have 2 e's left over here. On this side, I still have my 2 minus 6, which is going to give me a negative 4. And then in this case, I'm going to isolate the variable, which means I'm going to divide by 2, and I get negative 2 is equal to e. Cool. And now the last example of what we're doing today is an example of a word problem, where we're going to have to create some sort of equation in order to solve this. So it looks like we have David and Katie, and we're comparing how tall they are. David's height is 18 centimeters more than Katie's height. Katie is 174 centimeters tall. Well, we're going to start out with Katie. Katie, we know if we represent her height as k, is 174. And now I want to create an equation using Katie's height to figure out what David's height is. So I'm going to say David's height is 18 centimeters more than, which would be represented by addition, Katie's height. So there's David's height, 18 plus whatever Katie's is. So I'm going to take Katie's height and plug it in. 18 plus 174 is whatever David's height is, which when we reduce that down, it's going to be equal to 192. So 192 centimeters. That's how tall David is. So let's take a look. Today we're going to be solving inequalities. Now, these are going to have the same steps as we did the other day. It's going to have one additional step when we multiply or divide by a negative number. When we multiply the entire thing, not just a piece of it, not when we distribute, but when we multiply the entire inequality. The inequality sign is going to change directions. Why is this the case? Well, let's take a look at a few examples. We know that 1 is less than 2, but if I multiply that 1 by a negative and that 2 by a negative, I get negative 1 and negative 2. We know that negative 1 is not less than negative 2. Negative 2 would be the smaller of the two, so therefore we have to change direction of the sign. Same thing with 7. 7 is greater than or equal to 1, but if I multiply both sides by a negative number, the negative 7 is now the smaller of the two numbers. And while this is very obvious with whole number examples, it's the same when we have an aspect that has a variable in there. Doesn't matter what's going on, if we multiply or divide by a negative number, it's going to change the direction of the sign. This is also, likewise, the same with an equal sign. If I multiply a negative 6 by a negative and x by a negative, the equal sign changes direction. But we don't really need to worry about that because the equal sign is going to be the same no matter what. So you've been doing this, you may not have been aware of the fact that you're doing it. So let's practice solving a few inequalities. We're going to solve a few of these together, and you're going to work on a few on your own. So let's go ahead and get started. We're going to follow those 4 steps that we did the other day. First off, we're going to check for any parentheses or brackets. I see none. The next thing I'm going to check for is, do I see my variable in more than one spot? And I do. And because these are on the same side of the equation, I'm ignoring that 15, and I'm saying n plus n is the equivalent of 2n. So I have 2n plus 7 is greater than 15. Then my final 2 steps are going to be isolate the term, isolate the variable. Isolating the term means getting rid of anything that doesn't have an n, getting rid of that 7, which in effect cancels it out. And we'll have 2n is greater than 8. Now that we've isolated the term, we isolate the variable. 2 is connected via multiplication. Let's go ahead and divide by 2. So n is greater than 4. So far, so good. Let's look at the next one. Let's look at this one. So here, step 1 is check for any parentheses or brackets. I see none. Step 2 is my variable on one spot. It is. Step 3 is isolate the term, which would mean I'd get rid of this negative 6 and this 5, which means let me go ahead and add 6 and subtract 5. That cancels out and that cancels out, which means I have a negative 6k is greater than 17 plus 6 is 23, minus 5 is 18. And my last step being I need to get rid of that coefficient. Now, this negative 6 is connected via multiplication, which means we need to go ahead and divide by a negative 6, which that is the rule that we're noticing. If I divide or multiply by a negative, it's no longer opening to the left. I'm going to open that to the right and say k is less than or equal to negative 3. And there is my answer. Now, some of you might be crafty and say, hey, what happens if instead of dividing by negative 6, how about I just add that over here and subtract the 18? Well, let's see what we get. If I have a negative 6k is greater than or equal to 18, and I add the 6k, I can't add it to the 18 because they're not like terms. I'm left with 0 on the left, 18 plus 6k, and then I'm going to subtract my 18. And you're like, hey, look at what I did. I moved it without changing the sign. But let's take a look at what you just did. K was on the larger side. And by the time we got rid of this negative sign, k should be on the smaller side, which it is. So even though I divide by a positive 6, and it's like, does not feel like we've changed the sign, negative 3 is greater than or equal to k. K is on the smaller side of the inequality, which means k is less than. It's the same thing we had before. K is less than negative 3. Negative 3 is greater than or equal to k. No matter which way we read it, you get the same answer on both sets. Next one we're going to look at are these. This one actually does have parentheses that we can go ahead and we can clean up through distribution. Are there other ways to solve this? Yes. We're going to go through this one method because I like the same 4 steps. It's an algorithm like we've talked about. If you follow these 4 steps again and again, you will always get to the correct answer. If you want to work it a different way, you're more than welcome to, but I'm going to show the same 4 steps in the same order every time. So I have a negative 99 is less than negative 12n minus 15. This is another one we want to be careful. I see a lot of students multiply the negative 3 by the 4, and they'll just drag down this plus 5 and not actually distribute it. Make sure when you see parentheses and you're multiplying, multiply it by everything inside the parentheses. So we've cleaned it up. Our variables all in one spot, which means the last 2 steps isolate the term, isolate the variable. So we're isolating the term by adding the 15. So we have negative 84 is less than negative 12n. And again, here it's the same as before. If I'm dividing by a negative, I have to change the direction of the sign, which makes that a 7. N is less than 7, or if I read it in the other direction, 7 is greater than n. The last one that we're going to work on are these 2. So this one, let's walk through. I'm cleaning it up, getting rid of any parentheses or brackets. Gives me a 42n minus 24. I'm going to leave these over here because nothing happened. My next step is I'm going to move my n's into one spot because I see them written out multiple places. So if I subtract my 3n, I get 24 is greater than or equal to 39n is 24. So I've put them all in one spot. Last 2 steps, isolate the term, isolate the variable. Isolate the term by adding 24. Isolate the variable. So 0 is greater than or equal to n. So that's what I get. These last 2 are special. We're going to do this one, and hopefully you can figure out what's going on with number 8 by the time you're done. If I look at this and I go through these series of steps, I get rid of the parentheses. In my variable, I put them in one spot. I have a 2x over here and a 2x over here, and I move them over. What I notice is they both cancel out, and I have negative 2 is greater than or equal to negative 2. My x disappeared. Now, a lot of you might stop and say, what did I do wrong? You didn't do anything wrong. You're in fact correct. And what we're going to say is negative 2 greater than or equal to negative 2? And the answer is yes, it is true. Which means that it doesn't matter what I put in for x. I can say x equals 6. Negative 2 is still greater than or equal to negative 2. I could say x equals 10. It's the same thing. Negative 2 is still greater than or equal to negative 2. And in fact, no matter what I put, negative 2 is always greater than or equal to negative 2, which means all of these values and anything you can think of is a true statement, which means the answer to this is this inequality has infinite solutions. There is no incorrect answer.